In hydrology and water resource engineering, next topic, infiltration. Infiltration is the process of entering rainwater into soil strata of the earth called infiltration. The infiltrated water first meets the soil moisture deficiency, if any, or excess water moves vertically downward to reach the groundwater table. This vertical movement is called percolation. The infiltration capacity of the soil is defined as the maximum rate at which it is capable of absorbing water, and it is denoted by F. For dry soil, infiltration rate F is more, moist soil infiltration F is less. Maximum rate of water absorbing by soil is called infiltration capacity. Next, maximum capacity of the water absorbing by soil is called field capacity. The rate at which soil is able to absorb rainfall or irrigation, it is measured in mm per hour or inches per hour. Infiltrometer is used for measuring infiltration. Infiltrometer is used to measure the rate of water infiltration into the soil. This consists of metal cylinder of diameter 25 cm and 30 cm and length of 50 cm to 60 cm, with both ends open. The length of the cylinder is 2 into diameter, which means 25 into 2 or 30 into 2. It is driven into a level ground such as about 10 cm of cylinder is above the ground. Water is poured into the top part to the depth of 5 cm and pointed is set inside the ring to indicate the water level to be maintained. The single ring involves driving a ring into the soil and supplying water in the ring, either constant head or falling head condition. Constant head refers to the condition where the amount of water in the ring always held constant, means the rate of water supplied corresponds to the infiltration capacity, whereas falling head refers to the condition where water is supplied in the ring and the water is allowed to drop with time. The operator records how much water goes into soil for a given time period. The major drawback of single ring infiltrometer or tube infiltrometer is that the infiltrated water percolates laterally at the bottom of the ring. Thus, the tube is not truly representing the area through which infiltration takes place. This is the most commonly used floating type infiltrometer. It consists of two concentric rings driven into soil uniformly without disturbing the soil to the least to a depth of 15 cm. The diameter of the ring may vary between 25 cm to 60 cm. A inner ring is driven into the ground, and the second bigger ring around that is help control the flow of water through the first ring. Water is supplied either with a constant or falling head condition, and the operator records how much water infiltrates from the inner ring into the soil over a given time period. Infiltration capacity rate curve, as obtained from infiltrometer, is essentially observed to be a decaying curve. Some mathematical expression to describe the shape of curve given by various investigators are Harden equation, Phillips equation, Kashiko equation, and Holden's equation. At first, Harden equation, Ft is equal to infiltration capacity inches by hour, F naught is equal to initial infiltration capacity, Fc is the minimum infiltration capacity, T equal to time since the start of a rainfall, K is the constant depending upon soil type and vegetable cover. Note, Fc is direct depend upon hydraulic conductivity. Wherein Phillips equation, F equal to A plus by S by 2 into T into 0.5, where F is equal to A into Tn, F is equal to AFn P plus Fc. Where here A is the minimum infiltration capacity, S is the initial infiltration capacity. Whereas Holden equations above methods A and N are constant, depend on the soil moisture and vegetable cover. Next one, double ring infiltrometer. Infiltration of water into the soil can be determined by a simple instrument called double ring infiltrometer. A cylindrical ring infiltrometer consists of single metal cylinder. These cylinders are partially inserted into the ground, and water is filled up to a margin inside the cylinder, and after that speed of penetration of water is measured with respect to the time and depth of penetration of the water inside the material required is cylindrical ring, one with 30 cm and another with 60 cm diameter. Wooden piece to drive the cylinder inside the soil. Hammer to dig the cylinder inside the soil without any disturbance to the soil surface. Next one, measuring bucket, measuring jar at 2 liters, metal plate, stopwatch to know the time interval in which infiltration has to be measured. Next one, measuring rod, 300 mm, the amount of water penetrate inside the soil within the specific time interval. Cover and plastic sheet, washcloth, etc. Next, the method for double ring infiltrometer method are: hammer 30 cm diameter, ring at least 15 cm into the soil. Drive the measuring rod into the soil so that approximately 12 cm is left above the ground. Hammer the 60 cm ring into the soil or constructed an earth bund around 30 cm ring to protect the soil surface when pouring in water. Start the test by pouring water into the ring until the depth is approximately 72,000 mm. The water in the bund or within the two ring is to prevent lateral spread of water from the infiltrometer. Record the clock time when the test begins and note the water level on the measuring rod. After 1 to 2 minutes, record the drop in the water level in the inner ring of the measuring rod. In inner cylinder, record the water level. Maintain the water level outside the ring similar to the at inside. Continue the test until the drop in water level is same over the same time interval. Note that at least 2 infiltration tests should be carried out at site to make sure that the correct results are obtained. Next one, measurement of infiltration. It's the first we saw, that's on the double ring infiltrometer. Read the two operation techniques. First one, constant head method, falling head. As we know, constant head, which means the level of the inner ring is maintained the fixed level. The volume of water used to maintain this level is measured. While in falling head, water take decreases, inner ring is measured. In both constant falling head, the water level in the outer ring is maintained at a constant level to prevent leakage between ring and to force vertical infiltration from the inner ring. Principle behind this are: the rate of infiltration determined by the amount of water that infiltrate into the soil per surface area per unit time. Infiltration can be measured by either single or double ring infiltrometer with the presence of usually lying in the double ring. Because of the outer ring helps to reducing the error may result from lateral flow to the soil. This is important to evaluate the soil properties for agriculture potential. The principle of the method is to observe the water level in the inner of two cylinder driven concentrically into the soil surface. The outer ring minimize the error due to flow diverse than vertical. The measurement can be carried out on the topsoil as well as in each of the subsoil, horizon and substratum. Infiltration characteristics of soil provide useful information on the acceptance of rainfall into soil, waterlogging of land. That's all about what are the types of infiltration and infiltration methods used for identifying infiltration. Thank you.